All right, so this second video on systems of three variables, we are actually not going to represent the solution in a parametric. Just for the sake of time this year, we're not focusing on that. So basically, for these next couple examples, I'm going to show you situations where you might get infinitely many solutions and you might get no solutions. And I just want you to see how that might look like when you're working through these problems. So again, we're going to call them A, B, and C. I'm going to decide a variable to get rid of. And by a variable to get rid of, I mean a variable to eliminate. So let's say I decide to eliminate x's. Those look good. What if I take b and add it to negative c? So 3x minus 3y plus 6z equals negative 9. And I'm going to make all of these the opposite. I'm going to eliminate x. So let's see, I'm going to get y plus 2z equals negative 9. Now I'm going to eliminate x again by taking 3a's and adding it to b. So let's see, negative 3x plus 12y plus 12z, I'm going to scoot over a little bit, equals negative, what is that, 72? And then add that to b. 3x minus 3y plus 6z equals negative 9. Let's see, my x is going to eliminate it again. I get 9y plus 18z equals negative 81. Okay, so now the way that I'm going to eliminate, let's call this D and this E, is I'm going to do, let's see, negative 9D and add that to E to get rid of those Y's. So negative 9Y minus 18Z equals positive 81, and then I'm just copying E. And look what happens. Cancel, cancel, cancel. You get 0 equals 0. Well, when is that true? That is always true. So in this case, there is infinitely many solutions to this. Not saying that everything will work, but so it's likely that it's something like this. Let's see, let me go back to that example. Something like this, where it's like there's a line of answers that could work for this. So that's an infinitely many solutions. And I'm also going to show you an example of what might happen for a no solution one. So this next one should be no solution. I'm giving you I'm telling you what's happening before it's going to happen. Let's see, this is A, this is B, and this is C. Let's eliminate X. I'm going to add B and C together first because I can just do it right here. I probably shouldn't erase or just cross those out. So I end up with negative 2y minus 4z equals 15. So we'll call that D. Let's eliminate X again by taking A, and let's take negative 2b. So negative 4x minus 5y plus 4z equals 23. Now double and make it opposite of this next one. 4x plus 12y plus 10z equals 0. So these again will cancel. We'll get 7y, we'll get 14z, and we'll get 23. So this is E. Now, I'm probably going to try and get the y's to eliminate. So probably what I'm going to do is I'm going to take 7D and I'm going to take 2E. So let's see, this will be negative 14y minus 28z equals 30. No, I'm taking that times 7, just kidding. 7 times 50 is 70 plus 35, so 105. And then if I double E, I get 14y plus 28z equals 46. Now look what happens. 0, 0 equals 151. When is this true? It's never true. So this would be an example of no solution. So just be aware of those two types of situations as you're working. If you get something that's true, then it's going to be infinitely many. If you get something that is